let's explore how we have to deal with histogram when we work with ggplot. So this is the basic function. Again, I'm going to start with the basic function of the ggplot. ggplot takes one function. ggplot is a function which takes one argument, which is the dataset name, and we have isPhysics, which is another function inside the ggplot function. After that, I have to identify what kind of geometry or what kind of figure I want to develop. I can develop a basic histogram with using this function and identifying the data set, the isPhysics, which connects different elements of data table to different elements of figure, takes just one argument, which is x, and x should be numerical. We basically have no y value. And the geometry or the figure is called geom histogram, which is again a function. How do I know it from these brackets? Let's develop a basic histogram. I put the what was the name of that? Yeah, the general function here for you. But before using the general function, I want to deactivate general function for a second, like this. And I want to remember what was the name of different variables in the diamonds data set. I can run this line, and I was just trying to know what was the name of different variables, and I really don't need all of these observations, number 2, 3, 4, 5, and 6. So maybe I can add another variable at the comma and say, hey, I just need one variable. I don't need 6. The default is 6, and by this argument, I can change the default from 6 to 1. Run the code again, and you see he's going to just show me only one variable. So let's develop a histogram. What I want to choose, maybe I can select this variable, which is a categorical, which is a numerical one. These guys are categorical: cut, color, and clarity. Okay, so I'm going to get rid of this hashtag, ggplot. The data, what was the data set name? It was diamonds, this one. And what was the isPhysics I was trying to use? isPhysics was caret, x equals to caret. And the geometry name was geom histogram. Histogram. If I run the code, this is the histogram that is going to appear. Okay, it doesn't look very good, but for now it's not important. So this was a basic histogram. Let's create a better one. Maybe what I want to do is I want to just change the color. So the color is black. Maybe I want to create a green color. First, I'm going to do it in the wrong way, and after that, I'm going to do it in the right way. If I want to allocate a constant color to my figure, I should put it here under geom histogram function, not here. Let's see what's going to happen if I put it under the isPhysics. I'm saying, comma, color equals to, let's say, green. I'm going to run the code, and I see it is not green. So something is wrong with this. The point is, since the green is a constant number, it's just one specific pre-known number, it should not be placed under isPhysics. So I'm going to cut it, and I'm going to paste it here. I'm going to run the code one more time, and I see green lines are appearing here. And this is green. Maybe I also want to fill it by green and explore the results. And yes, it works. However, this is not really my favorite use of ggplot function. Instead of, I really don't like to use a constant color. I can use, there are better ways of using this argument. So I barely, or let's say, I never use colors inside the geom histogram. In the majority of cases, I use the colors here. So I can say, let's run this histogram again, the initial histogram. And for the colors, let's select a categorical data. For example, color equals to cut. And this is the result. So I see I have different carrots here and the count of them. So for example, this carrot is has the highest frequency, and from the carrot with the value of 2, which has the highest frequency, the majority of them are ideal, as shown by this gold. And I also have a considerable and same amount of premium and very good. I can also see the distribution for the other cuts as well, but maybe I want to use the field function and make it a bit more easier to distinguish between different cuts. Let's go to the coding area, comma. I'm gonna say fill equals to fill them by their cut and explore the results. I guess it looks better. So I see how is the distribution of this, this ideal cut in different carrots. And let's take a look here. Over here, it looks like I don't have many. It's a bit difficult to understand what's going on over here. But in the majority of cases, the ideal cut is the dominant type of part, dominant type of cut in different carrots. And after that, maybe I can say premium and very good cuts has the highest frequency, and the lower quality cuts, I don't have too many of them in this data set actually. Let's see, what do we mean by beans? So when I use, where is the definition of beans? Yep. So when we are developing a histogram, we are using different beans, which is basically different intervals, and in that, and we see how many observations do we have in different intervals. For example, if you consider this message from the R, it says 30 beans are used for developing this histogram. So it means from here to here. I know that the minimum is 0, but and the maximum is something about around 5. But there are different number of beans. For example, one bean is from here to here. For example, let's say from 0 to maybe 25. Then I have another bean. The frequency is a lot, and another bean, and so on. Maybe I really don't like this presentation, and I want to change the number of beans. The number of beans, as you can see here, should be changed inside the geom histogram function. So the default was, as I said, was 30 beans. It means I have 30 different intervals. What's going to happen if I have 20 intervals? I'm going to say beans equals to 20. And I'm going to run the code, and I see there's a bit of difference in the distribution, right? Because I have less amount of beans. Some people are asking me, like, do we have any specific rule to choose the number of beans? Not really, but we can explore different beans and see which one of them gonna give us the highest amount of information, or which one of them is appropriate for me to explore the data set. I'm gonna do the same thing. I'm gonna try a few different beans. 15, not bad. 10, okay. I guess 10 is good. I guess 10 is good. Or maybe I can also try 8. Okay. I'm gonna choose the 10. I don't have a very convincing reason for this, but it is informative. It shows me, that you see this skewed. So it's a right skewed histogram. So it looks like there's a very amount of data here. It's empty. So after caret of 2, I have very small amount of diamonds. However, before that is the majority of, before 2 caret is where I can find the majority of diamonds in my data set. Let's say you don't want to work with the number of wins. What you want to work with is the length of bin. You can use the argument bin width instead of bins. So we are coming to this figure, you explore it, you see it starts from 0, it ends in somewhere around 5. You are saying I want to have uh, bin width of 1. Let's try that. I can say bin width equals to 1, and you see 1 width of 1, 2 width of 1, and so on. But I watch this histogram and I think it doesn't look very good. I'm gonna change it to, like, let's say 0.6. This is very similar to my to the histogram that I get by by using the argument beans equals to. And I can also try other bin widths to see which one is the most appropriate for my investigations. I want to use an extra layer of facet wrap to create different partitions for different cuts. However, what I really don't want to do is, writing after this, because, the argument is already very long. Something which is usual for the people who use ggplot is allocating the ggplot function and everything inside the function to one name inside the R, and adding extra layers by their names. What do I mean by that is I'm gonna delete this geom histogram, so we don't have any geometry, and if I run the code, I'm gonna get something empty. However, I know I have a data set, and I already identified the x of the geometry, which will be selected later, should be caret, and they should I should have here I should have legends by the cut, and they should be filled by the cut. I can allocate them to something which is called uh, maybe G. Maybe G is not bad. I can allocate this to this. Nothing appears. But the G, which is this function with all of the components, I can add a layer to the G, which is, let's say, geom histogram. In this case, I can run it, and you see the result is the same, but the code is a bit more readable. I can change the bins to 4, or it wasn't good, or maybe to 10. Not bad. And I can add another layer of facet wrap, and I want to use the same variable I used in the for the colors. I'm going to use the wrap, and I'm going to partition them by their cut. give it some time to and let it load the data. And this is the result. And as you can see, different cuts: ideal, premium, very good, good, and fair. I have a different place for every one of them. And in the x-axis, I have the caret, and in the y-axis, I have the count. I see the distribution of the fairs. How's the distribution of the fairs? Fair cut. How's the distribution of the caret for the goods? Very good, and ideal and premium. This is very flat. The fair is very flat. However, this one, the ideal, has the highest variability. The variability of the premium and very good looks like to be very similar, and the variability of the goods is a bit more than fair. By the way, it looks like in the majority, I mean in all of the cuts, the majority of the carets are focused somewhere here, and here.